In this video, I'll demonstrate how to use the least cost path operations in ArcGIS Pro to determine some of the cost distances and some other layers that are important to that. And the ultimate goal is to navigate from this point to this point, given this altitude here or elevation here and this elevation here. We're also going to add some roads. So we'll figure out, given these road locations, how does one navigate from here to there, and we're going to combine the roads and the elevation and weight them so that, because roads in this case hypothetically are harder to cross, we're going to add more value to them when the computer determines which route to take. We will turn that off. This is the DEM we're dealing with, and we can do all this in ArcGIS Pro's Model Builder. And the first thing we want to do is to create the workspaces that we're going to work from. So I'm just going to create a new geodatabase here. We'll call it least cost path new, because this is today's, not used this one before. So this is going to be our workspace, and this is going to be our Scratch workspace, and I'll show you why that's important here in a sec. First thing we want to do is calculate slope, because that's going to be one of the main factors in where the line will put itself. So that's our input raster. And now what we can do is we can just name this Scratch. Actually, we need to do this, and we'll say Scratch workspace slope. Now what this does is, this is a wildcard to say wherever the Scratch workspace is. And this is important because I could make an entire model and then send it to you, and you would have to change the locations, right? If this said Justin folder, desktop, something, something, this folder, that folder, you would have to change each one of these to yours. But what you can do with this is simply go up here, change your Scratch workspace once to wherever you want to work from. And then when it sees this call, again, these percent symbols indicate wildcard. So it's saying whatever the Scratch workspace is, save it there and save it as slope. So we can do that, and we'll give this a quick run. Cool. So it looks like that finished. And we want to reclassify these values. And then we also want to take the road layer and convert that to a raster. So we'll say poly or line feature to raster. There's a couple different names for it. So here's the roads layer. So we'll put that right there. We will say input, and then the output, we know we can just say, we'll do this one more time, and then I will copy it all so I don't have to type it every time. So this is going to be roads raster, and then, so that's good there. And then while this is running, we'll go add the slope. Oops, sorry. Invalid workspace. So let's actually look what I did here that's wrong, because I do that stuff all the time. We will just copy that. Scratch workspace. Good. And this should work. All right, so let's go back over here and add slope to make sure that what we're seeing is correct. So where are our databases? LCP new. Nothing in here now, but if I refresh it, we get slope. So this is what that looks like. What are we seeing here? Yep, volcanic feature. Yeah, definitely steeper, darker values on these sides. And what is a darker value? It's a higher degree slope. So that looks like it came out right. Cool. And then we have these road pieces here. All right, so let's go back here, and now that we know what those slope values are, we can reclassify them. So we can now add, so let's say we want 0 degrees until, let's say, 20, and we'll name that 1, and then we can hit enter 2, and then I'll hit shift tab to go back, and let's call this 30, and then we'll call this 20, and we'll go 30 to 40, or let's just say actually we'll go bigger increments. So 30 to 45 will be class 3. And these new classes, these are going to be what weighs more, because 4 is going to be worth more than 2, right? It's twice as much. So that's going to say a steeper slope means a harder path. So we'll call this 65 and we'll call that 40. And what we'll do is we'll actually do a couple different iterations of this with different slope values, slope classifications, excuse me. And we'll call that 90 and we'll say just 5 for this one. So we got that, and then we'll say slope reclass 1 because we're going to have a few different slope classifications. All right, all looks good. And we can run that. Done. Okay. All right, so the next thing that we want to do is work on this roads layer here. And one of the things you'll notice when you get to this with this road layer is it's just the road. So that begs the question, if it's just the road, how do we do math with the surface here, the raster that covers this whole area, and add that to this rasterized roads layer? We need to add those two together, but they don't encompass the same surface area. So we need to add roads or an area that's not roads to the roads layer so that will either be a 0 equals not road, a 1 equals road, and then we can do math with the slope layer beneath it. So let's first copy this raster into a new raster, and this new raster will have the ability to change it to values of only 1, and the rest is all set to null. Oops, sorry. So we're going to copy this raster, we're going to change that, and we're going to say pixel type equals 1 bit. So that means anything that's a road is automatically a 1, and everything else is 0. And we'll just name it copy raster here. Where are we saving it? Yeah, same Scratch workspace. Okay, looks good. We'll hit save. Okay, so let's run that. So we're just creating a new raster. And let's just check right here what that came out as. Refresh this. Roads raster, copy to new raster. Yes, all the roads are valued at 1. It's just values of 1. So that's good because in the next step what we can do is we can run a conditional statement, and you can either do that with the con tool or you can do it in Raster Calculator. And I prefer to do it in Raster Calculator. That's Image Analyst. We'll just get in the habit of using the Spatial Analyst version. And we will run this in here. And now what we're going to say is conditional. Of the is null within this roads raster copy raster, within that, name them to 0, not is null. Because everything that's behind this right now, all the area that's not road is null in the roads layer. And 1 is the road. So over here, then we say name it to is null. Otherwise, that's part of the conditional statement. Otherwise, name it what it is, which would be a 1. So let's see how this runs. Okay, looks like we got that worked out. Now let's add that layer here and see what we came up with. So this is going to be the roads conditional layer. And great. So all these values out here are 0, which is what we wanted. We didn't want them null, which is what they are in this layer here. They're just nothing. So that's good. Now we can do some further steps. And now we're going to add another raster calculator. And what we want to do is add these together after they're weighted. So let's just say, all right, we want slope reclass 1. We want to find the layers here that we've got. Slope reclass 1. There we go. So we have that. And let's make this only 35% of the weight that we're gonna tell the computer to consider how difficult a place is to cross. All right, and then we'll do the same thing with our roads conditional layer. So we'll add that, and we can go like this. We'll say we'll weight that 65 because it's hard to cross a road. And then what do we want to name this as an output layer? We want to name this weighted surface. Can't make it too much longer than that, or Arc will give us a warning. Okay, so this looks like it's good. We'll give that a run. Looks like it worked. Okay, so now we have a weighted surface. let's take a look at that weighted surface. What should we find here? All right, so what we can see is not a ton of difference, and that's okay, because we're going to see something different when it comes to when we change the values of the reclassified slope later. But that's all right. So what we can see here is a lot of these values are pretty darn low. So we're thinking this probably won't make us go straight through here and cross all these roads. It might make us go around here, cross this road, cross that road, etc. But that's all right. We'll see what it does. So the next step here is to run a cost distance. And this is measuring the distance away from the first point, the starting point. Tell us how much that costs. And so when we drag the weighted surface in here, it's the cost raster. So we have that. Okay, cool. Well, what's the other thing that goes in here? And you can see up at the top there, it says input raster or feature source. So that's the start point. This is the feature of the source. All right, what do we want to name it? We will name it cost distance. Okay. And the output backlink we'll name this backlink. Okay. Very good. So it didn't like that. So let's try this again. See what we get. And there, it worked that time. Doesn't like file path names when saving in geodatabases. Sometimes seems to require them, but all right, so now we're actually going to create a cost path, and we need to add the backlink to this, and the backlink has to do with the movement backwards. So if you're going from one point to the next and were to turn around, what type of resistance would be faced? And it's actually a little bit more complicated than that. I encourage you that you read up on it on ARC's website, especially because a lot of GIS programs, including RQ, don't require a cost backlink layer. So keep that in mind. All right, cost distance, yes, and now we need the endpoint. Where are we in fact going? Featured destination. Okay, what are we going to call this? Let's call this PC wall path. And let's give this a run. Okay, so what we should expect is a pretty straight line for LCP here. And yes, it's very straight because slope didn't really matter too much. But we're going to change that this go around. All right, so let's go back here real quick and change slope the classifications. So now let's make this 0 to 5. And actually, let's make it 0 to 4. Really get our money's worth here. We'll make that 0 to 8. Okay, and we'll call this slope reclass that, and we'll give this a run. Okay, that's done. Now we can go in here. All these should be the same. This will need to be redone because it's slope reclass not 1, but 2 now. Weighted surf, we need to change that to 1. Okay, we'll run this. Let that go. Okay, actually let's make slope count a little more. Slope is actually going to count for 40%. Rows are only going to count for 60%. Okay. All right, so now we have weighted surf 1. Okay, it's accepting it in there. That's good. So let's run this. Done. Last but not least, and we will change the name of this so we don't overwrite it. That way we can put them both on the map at the same time and see how they differ. All right, that's done. So let's add least cost path numero dos. Yes, okay, so you can see it's more sensitive to slope now. Knowing what we know about slope and where it sits, right? Slope is right here. We can even take slope off and we'll get a nice hillshade, and you know that these are higher elevation areas. These are roads. So this time this was more willing to go out of its way to cross a road at a point where there's less overlap, right? There's only this much overlap as opposed to a clean full swoop of going across the road. Then it straightens itself out a little bit, keeps going around here, jumps across a sliver of road right there. Okay, then moves along its way over here instead of going straight over the top. If we were to put slope back on there, you could see that this is avoiding the darker areas because those are steeper, right? So you can see that there. Every time it's about to go into a, like this line, it would either hit this, this, or this, most likely. So it turns, goes parallel on the side of the slope for a while, still hugs it because its destination is up this direction, avoids that, and so forth. No major things in the way here, so it can kind of go like roundly, and basically contour the edge of the mountain there till it gets home. Hits this bump, decides it's better to sidestep, go up here, jump across the creek, and it makes it there. So that's kind of a cool way to do that. I hope you were able to glean some other ways of doing things, some other cool features and other things that you can do with ArcGIS Pro's modeler. And we could also make similarly complex things in R. We just didn't for this specific lab, but it is possible. And let me know if you guys have any questions.